online participants to MEDOCnet, welcome to the discussion of this session, whose title is 5G and Beyond, from Energy Management to Global Scheduling and Performance Boost. I am Luigi Fratta from Politecnico di Milano, and I am co-sharing this session with Vincenzo Mancuso, that I will ask him to switch on his okay. Hi, Vincenzo.
Morning, everyone.
In this session, we had seven excellent papers accepted, and I would say that is the best session since we have both awarded papers are presented in this session. The Mario Gerla best paper and the runner-up best paper. First, I would like to ask the speaker present here to switch on the light, the video. So I would like to go around and themselves to very briefly introduce.
Okay, I am Daniela Renga from the Politecnico di Torino. I'm currently a postdoc, and the main focus of my research activity is about green mobile networks, both in terms of network modeling and using especially renewable energy to power mobile networks and to dimension renewable energy system and to investigate how renewable energy can be effective in making a green system more feasible, less costly, and of course allowing to reduce the carbon footprint.
Thank you very much. Azim?
Okay, so I am currently a master student at the University of Padua, and I'm focusing on the performance optimization of 5G and beyond networks, and in particular in the achievement of network slicing. And I'm currently working on my master thesis, in which I'm actually working in the optimization of the EAB deployments.
Okay, thank you very much. So move to paper 3, Valero here.
Yes,
Paper
I'm here. Hello, everybody. I'm Greta Vallero. I'm a PhD student from Politecnico di Torino, and my research focuses on energy management in wireless access networks.
Paper 4, Rago.
Hello, everyone. I'm Arcangela Rago, a PhD student at Politecnico di Bari. And my research activities are focused on machine learning and deep learning for network optimization.
Thank you very much. Next is Zhang. Congratulations for the award of your paper.
Okay. Hello, everyone. Nice to see you here in MedComNet 2020. My name is Bibo Zhang from Politecnico di Milano. My research interests include resource allocation in 5G and beyond networks using mainly a machine learning paradigm. Thank you.
Okay, thank you very much. Who is the Patrone?
I'm a postdoc researcher at the University of Genoa, and the topic of the paper is the gateway diversity in a satellite communication network.
Okay, the last paper, 7th paper, Bruschi.
Hi, I'm Valerio Bruschi from the University of Rome Tor Vergata. My research interests focus on stateful programmable data plane and traffic monitoring. Thanks.
Okay, so we know all the speakers, so we can start asking questions to all these very good speakers. And I would like to start, the single paper that have addressed specific topics and different technology. So I will start the discussion with a general question. The question is taking into account that 5G networks and beyond are characterized by several technologies, which will be the aspect more relevant for the future. So which future direction should we follow? And more specifically, what is your guess on the impact that technology you have studied in your paper will have on the use of cellular network that will be done by customer and operators?
By the way, if I can, I would say that for the next few questions, we would like to have questions from the floor. So since we are more than 50 people connected in this moment, maybe the best option is if you drop your question in the chat. So I will have a look to the questions, and when I can actually call you to make the question and with your voice. But while the authors are answering this first open question to everybody, I invite everyone to write questions on the chat box, please.
Yeah, if I may, I can start. Maybe someone else then can follow me. I guess that different from all the previous version of mobile communication, so 2G, 3G, and 4G. 5G contains a higher number of changes, which goes far beyond the simple improvement of the cellular technology and the cellular networks. So just in my case, I'm studying satellite communication, and in particular, one topic related also to the 5G and beyond is the integration between terrestrial and satellite networks. That is because also related to the 5G, there are a higher number of possible use cases with a very high heterogeneity of requirement. We can have the IoT in urban scenario, rural scenario, or the multimedia content on a moving platform such as airplane or train. So a lot of different use cases with a lot of different technological requirement and needs. And so a lot of technological means also, like satellite, that could be integrated to the terrestrial network in order to support it and to improve the performance for all the kind of different users and needs.
Thank you. Any other comment?
So while you guys are thinking about questions, maybe a follow up for the first question. So actually, I've been reading your papers, very interesting papers. Some are short papers that introduce some new ideas, but quite challenging research topics. Actually, some others are more consolidated, work on more consolidated things. There are many aspects. I've seen many aspects to consider for future networking, from millimeter waves to using new hardware or new programmable hardware, like the work of Valerio, the many works on energy efficiency, for instance. How do you see all these things together? For instance, maybe I will ask Daniela. I already asked many questions to Daniela. So how do you see this very power expensive applications running on green base stations, for instance?
Well, I think that this is a big issue that needs to be addressed, especially in a 5G context because also linking to the first question, the 5G paradigm envisions a huge variety of services that are provided to the users, and maybe they have very different requirements in terms of bandwidth, but also in terms of quality of service. So first, we need to put together a lot of different services that may need also, let's say a proper infrastructures that must be deployed. For example, focusing on the specific scenarios that we are investigating with our group, the mobile access networks should be densified to address the increase of the demand, but also the variety of services that should be provided. And of course, this must be balanced by introducing some methods that allow to make the network greener, to keep it greener, because for example, also okay, we have a new base stations that, for example, will have a consumption that is more proportional to the traffic demand, but of course we will have an increasing number of them. So we must act for example, by introducing resource on demand or by exploiting, for example, renewable energy sources, coupling the introduction of these resources with a proper energy management. Also because, for example, in a urban environment where we can think of a lot of 5G application, maybe we will have also physical constraints that won't allow us to use, let's say, a huge area for deploying our renewable energy system. And so, for example, with our work, we are exactly investigating the possibility of exploiting renewable energy sources in physically constrained environments, for example, to power base station in a urban environments where we have a small space to use installation of photovoltaic panels, and maybe they must be really distributed. And also there are other issues to be addressed, because, for example, also the softwareization of services maybe requires a lot of energy that we cannot think of at first sight. And so it is really required an integration of different aspects to be taken into account to balance the requirements with energy consumption and energy efficiency.
Thank you.
That makes sense. The problem I see for people like you, like me, also working on making internet greener, is that new applications like AI, artificial intelligence, machine learning in particular, but also what, for instance, Valerio was proposing in his paper, this net puting, they require a lot of energy, and the more you evolve, the more they ask for. So, Valerio, for instance, can you give us an example of what you can do with your net puting? Can you first of all explain us what does it mean?
Yeah, it's an interesting paradigm, because we try with our programmable hardware that in our paper we propose to use programmable hardware, since I'm more focused on the core network, coming back also to the first question for further direction in networking, that we can exploit this programmability that we have inside the network to try to do in an efficient way different tasks. Starting from network routine task that in the last 5 years we are seeing in most of the paper, that moving to P4 or also in flow blades, we are able to develop different network function. We would like also to try to do some more computational demanding and upper layer task to these devices. Some examples are related on the online MapReduce offloading, in which we have some traffic that is moving inside the network, and we are doing some data aggregation that are not related with the network, with the network manageability. So there are some information that are aggregated and then sent to some interested in that kind of computation. And we were able to do this kind of task in an efficient way, because we're able to exploit hardware that for sure has is less demanding in terms of power, and also have a lot of high performance, because we just have an hardware that do that kind of task and do it extremely well. So this is the sense of our position paper.
Thank you very much. I think it's very interesting, and the future, I hope we will have time to discuss about it.
Mm-hmm. Yeah, if I have other time to spend, we
unfortunately also, in the interest of time, we have to run now, because we have few minutes. Definitely, it's very interesting what you've done. So I see there are a couple of questions. One from Giuseppe for Matteo.
for both the papers. I mean, there are 2 papers on millimeter wave, and basically my question is, how far is research from real-world deployment? That's the point. That is, I saw that the methods you used are either simulation or experimental, but using fixed technologies. So how far is before millimeter wave comes into real play? I mean, it's a 5G technology or it's a beyond? That's my question.
Okay, so regarding our paper, which is the achievement of network slicing by a carrier aggregation, in my personal opinion, I think it can be used for 5G networks, not necessarily beyond 5G networks. And regarding our methodologies, yes, we are focusing on simulation, but we are still using a very realistic simulator, which is NS3, and with its millimeter wave models and so on. And furthermore, there are still it's still very costly to test in an actual 5G deployment. So that's why we focus on simulation. But in my personal opinion, our solution is it's not too far from being usable in an actual deployment.
Bibo, do you want to add any comment on this?
Yes, because I'm studying on the IAB architecture of the millimeter wave based networks. So I'm gonna give some comments, give some answers on this question from this side. For the millimeter wave IAB networks, because it can enable more flexible network deployment. For example, the IAB relay nodes can be installed easily and with the much lower cost and higher density by the operators compared with the traditional mobile radio networks. And with a high probability, this architecture will also be included in the standardization process in 6G. I think it will be easily implemented. Yes, and for the millimeter wave, because the millimeter wave can enable much data rate, so that can allow many customer-friendly applications like augmented reality and virtual reality to be served to people. And millimeter wave can enable high data rate and low latency, but it can also meet some meet some path loss and obstacles. Yes, but IAB architecture.
How far are we from making those obstacles easily easily solvable? But that's a real question. On paper, I see you have provided very good results and techniques, but in reality, is it going to be next year or in 3 years, or in 5? That's a question mark. Well, we don't know. The industry will have to help with that. So let's move. I see more questions. I see Falco wanted to ask something to Greta. Falco, do you want to ask?
Yeah, I would like to. With very much curiosity, I went through this paper, coping with power outages in mobile networks, because this is really a step into a direction which nobody really thinks of, right? We always assume our mobile cellular networks are just available, but they are not. So we need to do a lot of things about resiliency of these mobile networks, and this Greta's paper here is a great contribution to this, I think. So my concrete question is, at the moment, this is only focusing. It's a great paper, but at the majority focusing on the wireless communication services as such. Now with the next generation mobile edge computing solutions coming up, where you have compute power at these base stations as well, do you think it's scalable to this? What are the challenges for the next for your next paper, I guess, where you incorporate mobile edge computing?
So thanks for the question. Well, actually, we are working on this aspect, and so to consider also the MEC technology in the wireless access network and address the problem of power consumption when this technology is used. Actually, the idea of also include an availability of energy supply could be interesting. And of course, the problem is that when energy is not available, the MEC technology will switch off. And so a kind of reconfiguration will be needed. And so also this aspect should be considered also in terms of time and also in terms of of critical aspect that should present this situation. And nevertheless, well, at the moment we are also working on this and mainly looking at how the MEC technology impacts on the energy consumption of the network. And actually, this energy consumption doesn't not increase so significantly because this increase is around 10%. And so actually, well, cover this is an increase, but well, it is something that is limited.
Yeah. Okay. Thank you very much.
Other questions from the floor? Okay, Arcangela, can I ask you a thing? In your paper, you have evaluated a simple workload for your artificial intelligence application. So, how does it scale? How does it go when you have a real traffic matrix in the network? I mean, what is the complexity of training, for instance, the artificial intelligence algorithm you're using when you have a reasonable number of different classes of users, of types of applications to be considered at the same time?
Oh yeah, thank you for the question. Yeah, it is the more critical aspect because we just propose an introduction of our activity. So we propose let's say NFV compliant architecture that predict spatial temporal user dynamics. And so knowing in advance the dynamics of user and also their requirements, we can distribute and deploy resources and functionality considering also the mobility. And so of course we have to consider a lot of use case. We start considering just one use case, autonomous driving, and then we are working on this to implement optimization algorithm, so to optimize the resources and functionality that the user requests.
Okay, thank you very much.
Okay, I think Vincenzo, should we close the session or?
If I can have one more minute, I think we have one of the authors didn't say anything, so I would like at least to tell. We have the Patrone. Sorry, I forgot your first name. Fabio. You're not there, so we probably were.
Yeah, he was the first to talk.
Present, but we know you're there. So can you briefly tell us what's a real challenge in satellite networks for 5G? Why can't you reuse network slicing or carrier aggregation things in order to achieve the diversity that you are looking for in your proposal?
Thank you for the question. Really good question. Maybe a simple, brief answer could be that most solution for the 5G has been designed and developed for terrestrial network. So the application or the employment of these techniques to the satellite network could not be forward. A little bit more detailed answer could be, okay, we know how the 3GPP and the standardization activity is doing this standardization work. We know the more research efforts on on all the technologies we can say there are within the 5G framework, and we know which are the requirement and the features of the satellite communication. So we know that we will always have a higher delay, because even if we consider a low Earth orbit satellite are at least at 400 kilometers up in the space, or even more. We know that they are moving quite fast, so Doppler and all the other effects related to the mobility, and a lot of other things. So the main challenge is not to develop new things, or I mean not just do research only focusing on satellite communication, but to understand how we can change a little bit the one developed for the terrestrial network in order to be compliant for the satellite communication in a completely transparent way from the end user. Because obviously, if the end user want to, I mean, look at the video on YouTube or download his or her email, he or she doesn't care if their data pass through a terrestrial network or a hybrid terrestrial satellite one. So the KPI defined for the 5G for the terrestrial network has to be fulfilled also for the satellite one. So these are the challenges that first of all the satellite communication community, when we talk about 5G, need to focus. And there are quite a lot, and some could be easily addressed and some other not so easily.
But can you put solar panels on the satellites so that we can close the loop with the first question? We go back to green base station.
For sure. I mean, the solar panel are the main. I mean, I guess 95 or maybe even more percentage of the satellite are powered on by solar energy.
Those agree.
But anyway, the available surface could be not so wide, so also the amount of generated energy is not so high. And then there are the shadow period where the Earth is in the middle between the sun and the satellite. So we also need battery and so on. I could go on also along, but yeah, for sure the energy consumption, the energy resumption is quite challenging also for the satellite point of view.
Thanks. A lot of challenges as we look for the future. I think we should stop, otherwise Renato will kill me.
Yeah. Thank you very much for the speaker. Thank you.